Okay, let's talk about the sense of taste. How do we taste? Well, as I was saying before, that it's chemoreception. You are sensing chemicals that are dissolved in the saliva. So we eat food, and there are chemical substances in the food that we are able to detect through the sense of taste. We have these crevices in our tongue, the papillae of the tongue. They hold our taste buds, and the taste buds are the receptor cells for taste. So the taste buds are, as I said before, those specialized cells that respond to specific stimuli, and in this case, they respond to the chemicals dissolved in our saliva. They translate the message into a neural signal, that's the transduction, and send the impulse to the parietal lobe of the brain. So this is essentially how we taste. So here's a close-up of a taste bud, and you can see this is where it picks up the chemical signals. Again, it sends it through the gustatory nerve to the brain eventually. Basically, our sense of taste is limited to a relatively, it's a pretty small number of tastes: sweet, sour, salty, bitter, and a fifth one called umami, which is kind of like a savory taste. But basically, the sense of taste is really just these 5 tastes or some combination of them. So we have the ability to detect, things that are sweet, things that are sour, but basically that's it. And when you think about it, you have to wonder, what is it about the food we eat? We taste so many different things, and you think about wine tasters who can taste so many different years of different wines. It seems hard to believe that they can make those distinctions if our taste only consists of these 5 basic tastes. But it has to do with other factors. One of the things it has to do with is that our sense of taste interacts with other senses. So, for example, the sense of taste is very much our personal perception of taste, I should say, involves a lot more than just what is going on the tongue. It is the smell. It is the texture. It is the temperature. Hey, if you like eating hot and spicy food, the capsaicin in hot peppers, well, they stimulate pain sensations in the mouth. So the actual the sense of pain that you get from eating hot foods is actually part of the pleasure of the food that we eat. That is, if you like spicy foods. So there are many different factors. So smell is a big part, because smell, we can actually smell a lot of different smells. But taste itself, there aren't that many things that we can taste. So it's that interaction. And again, you think about what it would be like. Imagine, if you like a po' boy sandwich. Imagine if the po' boy sandwich with the same ingredients was just soggy, and then it would be disgusting. You wouldn't want to eat it because that's, again, the texture. It may be the same food, but the texture of it would make it unpalatable. So it's the sensory interaction that puts the picture together of the food we eat. And if you think about it, if you recall any time you've had a really bad cold, you've had a really stuffed nose, you couldn't breathe through your nose, well, your food probably tasted pretty bland too. And that was because you couldn't incorporate your sense of smell with the food you're eating. So let's talk a little bit about the sense of smell. Smell is a chemical sense, just like taste, except we're smelling the chemicals that are floating around in the air. called odorants, those chemical molecules. And we can actually detect quite a few, many different smells. A lot of smells, not a lot more than just the 5 of different types of taste. So we have the receptor cells. Again, these receptors turn the through transduction, turn this into a neural impulse, send the impulse to the olfactory bulb, which is the smell center in the brain. And if you look kind of at the structure here of the human olfactory system, the olfactory bulb is inside the brain, and the receptors go very quickly, very directly into the brain. It's a very short distance between the olfactory receptors and the brain. So there's a lot of evidence to say that the sense of smell really does hit us very hard. We react very strongly to certain kinds of smells. Like a smell of, the really bad smell really, yields to like a negative emotional response. Likewise, we learn very quickly through smell. You can be very attracted to somebody, and learn to basically, be attracted to associate the perfume someone wears with attraction, and therefore you feel that emotional response that comes from smell. So smell is very powerful. There is even a lot of, if you think about animal research on pheromones, how the sense of smell, how messages are sent via the sense of smell, how animals mark their territory, for example. Other animals detect that, what they leave, their smell, and they know to stay away. So pheromones, you think about sending chemical messages through the sense of smell. And it turns out that humans humans do respond to smell. And there is some suggestion that that there are pheromones that humans have in the smells that we emit. And we send chemical messages too, perhaps without necessarily even realizing it. For example, there's a very interesting phenomenon called menstrual synchrony. And if there are any women who are listening to this lecture here, you might have had experiences where you might have been living with other young women for an extended period of time, and you might have noticed that your menstrual cycles became synchronous. You might have noticed that you had your periods at the same time. And there is some evidence that the sense of smell is involved in this phenomenon. There was a researcher, I don't remember her name, but she she got a group of women who never met, never had any physical contact with each other. And in their subjects, she basically collected sweat samples from them, from their underarm. And they had all of the women sniff the sweat sample from all of the other women. So they never actually met, they just sniffed the sweat. And what happened was, over time, their cycles did become synchronous. So it's a suggestion that maybe some chemical messages are being sent and received through the sense of smell. Women tend to be better at detecting odors than men. Women have a keener sense of smell. Also, for both men and women, as we get older, our sense of smell decreases. So perhaps our food doesn't taste quite as good, quite as flavorful as we get older. Also, women, if you think about it, you might have even had different kinds of peaks and valleys. If you think about a time in which you were pregnant, for example, for any women who are listening who have been pregnant, you probably know that your sense of smell is a lot keener, a lot stronger when you are pregnant. So a lot, so some of the hormonal activity that's going on during pregnancy apparently is having an effect on your sense of smell. Let's talk briefly about some of the other senses in the sense of smell, the skin senses here. Think about the pathway, the receptors, the skin receptors in your skin send a message to the spinal cord, then the spinal cord to the thalamus, and the thalamus is kind of like a sensory switchboard, sends the incoming messages to the appropriate areas of the brain. And it goes to the somatosensory cortex of the parietal lobe. We have senses that are thermoreceptors that respond to temperature, warm and cold. Interestingly enough, we don't really have a skin receptor for hot. But when we detect something that is a very hot temperature, it's the warm and cold receptors that are being stimulated simultaneously. If you can think about this, the cold sense, something that's very, very cold, also there's a sense of pain as well. So you can see the connection here. That's why something that's very hot might be considered painful. So here are some illustrations of different kinds of sensory receptors. And again, some of these receptors sense, light touch, some of them deep touch, some of the vibration. So, realize that we can sense different variations of just the one thing we call touch. So the sensory neurons, they register the pressure, they send it to the thalamus, as I said before, and goes to the somatosensory cortex. Let's talk a little bit about pain, another important sense that we have. If you think about pain, we actually have two pathways that have been identified, different neural pathways for different types of pain. The one type of pain, the sharp feeling pain, so when you step on a nail, that's that quick, sharp pain, and you feel that quicker. It travels along myelinated neurons, and if you recall, the myelin around the nerves, speeds up the transmission. So the myelinated neurons, they're going to have a faster transmission, and you want to have a fast transmission when you step on a nail because you don't want to keep on stepping down. You want to move your foot away. So the faster you can detect the pain, the faster you can keep yourself out of danger. Meanwhile, you might also have a slow burning pain when you have a headache. You know that it's not an immediate thing that you need to deal with, but it's just a nagging pain you gotta kind of deal with over time. It's going to go along a slower pathway, not something we need to necessarily take care of right away, but just something to remind us, hey, we're sick, we're feeling pain, we got to deal with this. Now, for those of you who might suffer migraines, for example, who, boy, oh boy, you wish your pain would go away, you know that the fact that we can sense pain while pain is unpleasant, the inability to feel pain is a really, really terrible circumstance to have. When you are in pain, it tells you that something is wrong with your body, and you need to get it taken care of. If you are unable to feel pain, then you can be walking around with serious damage and not even know it. There are some individuals who have a very rare disease. Actually, there are a number of diseases that fit this description. CIPA, chronic inability to feel pain, chronic inhibition of pain with anhidrosis. So I don't think she even sweats either. This girl, Ashley Blocker, is unable to feel pain. So if she's also unable to notice if she's uncomfortably warm. Well, again, she can't feel it, she can't sweat. So the problem is she has in danger of hurting herself without even knowing it. And usually people who have this condition have a pretty short lifespan because of the problems associated with the injuries they can have. But anyway, I found a video that kind of This is a little update on Ashley's condition. So why don't we watch this video here?
First in this half hour, an inspiring story about a young girl with a condition so rare that no one, not even experts, know how many people it affects. It's known as CIPA, the inability to feel any physical pain. And that 12-year-old girl is using her diagnosis to make a difference. GMA special contributor Cameron Matheson had a chance to spend some time with her. Here's her story.
What if pain, the thing that parents try hardest to protect their children from, what if that was the thing your child needed most?
Everyone said, "Oh, what a good baby you have." But as time went on, the red flags started going up.
From the moment she was born, Ashlyn Blocker didn't cry when she was hungry or had diaper rash, or even when, at just 8 months old, her parents took her to the eye doctor.
When they put the dye in her eye, everyone just kind of gasped. She had a big corneal abrasion across her eye. They were astonished she wasn't in pain.
It was then her parents got the shocking, devastating news. Their baby couldn't feel any pain.
It was scary because, there weren't very many good outcomes that were involved with this condition. People passing away from appendicitis because they didn't have the warning signs, and bone infections.
I understand that the toddler years were some of the worst, where she continued to injure herself.
Yeah, the biting, her burning her hands, different things. Tar actually would wrap her hands up with athletic tape. She'd be our little boxer.
Photo after photo document injuries that pained her parents, but not their little girl. What is it like for you to send her out the door every day, knowing what can happen without you there to watch?
It was rough at first.
A medical mystery that for Ashlyn, now 12, I love this room.
Thank you.
I love the color, is just a normal part of life. How would you describe to somebody like me what it feels like to not have any pain?
It's just me. It's all I ever known.
You tell me which finger you feel it on, okay? Okay.
Hoping to learn more about this rare condition, researchers at the University of Florida have been testing Ashlyn since 2004. And a few years ago were able to pinpoint the exact gene that affects how strongly pain signals are sent to the brain. Findings that may one day lead to new pain treatments.
There's a reason for everything, and Ashlyn's here for a reason.
But for today, Ashlyn, just a normal 12-year-old girl who loves pageants and playing in the school band. And crocheting. It's turned into a fundraising tool for an astonishing family project. All of these you're going to sell, you're going to raise money for camp.
Yeah. Ashlyn had a dream one night that we started a camp for families like us. I knew instantly what I was meant to do.
We're almost there!
That dream became reality this past November when the family started Camp Painless But Hopeful and hosted 8 families also dealing with this incredibly rare condition. What was it like to see Ashlyn associating, having fun, and playing with other kids?
It was like
It was an amazing, unforgettable time for sure. I mean, to actually be in a room in presence of someone who knows what you've been through. I mean, know your daily life, your daily struggles, and know you're not alone anymore. I mean, it was just amazing.
Cue the music, please.
Yeah!
Maestro. In exchange for my crochet lessons, Ashlyn made me go back to my Dancing with the Stars days and teach her a waltz.
That's it. You're doing it.
A special moment with a remarkable young girl that I will never forget.
You should go Dancing with the Stars.
When you daydream about the future, what does that look like now for Ashlyn?
I think it's going to hold everything she wants it to.
So as you can see, having this condition is a very serious problem. It's important to be able to feel pain and be able to deal with it. And for the people who suffer from a condition like this, life can be pretty tough. You got to be very, very careful, and they can suffer some serious injuries. But nevertheless, with proper care and management, you can survive. Well, how do we deal with pain? For those of us who do suffer from pain, how do we deal with it ourselves? Well, our body helps us. Our bodies release endorphins and enkephalins, which are chemicals that have the pain-relieving properties. And so we have our naturally produced painkillers that help us cope with pain. If you think about it, imagine for any of you who might run, when you're running, it can hurt. You're feeling the pain in your muscles, but as you keep on going, you might get that second wind. You got that. You may get that even that runner's high from running, where the pain is reduced, and you start feeling those happy feelings, and that's from the release of the endorphins. So, we have our ways of doing it. We also have ways of helping us do that, such as doctors prescribing morphine when we are recovering from surgery or something, and we are dealing with very serious pain. Morphine helps to reduce pain. Heroin, too. Well, both of those are kind of in the same family of drugs. They are addictive, so you have to be very careful. But they also reduce pain. We can also find ways to reduce pain, through focused breathing. If you think about like a Lamaze class for women who are pregnant, you can distract yourself with some other task that can essentially, your pain will be reduced in that way. Counter stimulation, stimulating something else, some other part of your body, for example, using acupuncture, can also help you reduce pain. Finally, when you think about pain, you think about there are many different factors in our experience of pain. So the biopsychosocial model, in terms of looking at pain, realizes there are biological influences, there are psychological influences, and there are social and cultural influences. So, for example, some people biologically have a higher tolerance of pain than others. Not just people who have that condition that Ashley Blocker had, but just some people respond to pain differently than others. There are also psychological things. If we're paying attention to our pain, it may feel more intense, but if we're distracted from it, it becomes less. We can learn how to cope with pain better too. So this is where psychology comes into play. And finally, social and cultural influences realize that in different cultures, it's may be more or less acceptable to show open expressions of pain. Maybe for men, men are supposed to be strong and take it and not have to show their pain. Of course, that's we may not show it, but we still feel it. Finally, briefly, some other senses that we have: the kinesthetic senses, that's involving our movement, knowing where our body's moving, and you think essentially we respond. Our muscle fibers and the way our muscles are moving are sending messages to the brain. So proprioceptive feedback, so we kind of know what's going on with our body, or the way our bodies are moving. Get feedback from it. Essentially, our brain is able to detect what is going on there. Our vestibular senses essentially help us with our balance and our acceleration, keeping us steady. The semicircular canals in our inner ear help us with our vestibular sense, kind of like knowing where our head is, and keeping us from getting too dizzy and falling down.